Hi, this is uh, LeetCode 900, and in this problem, we are given an iterator initialized by a class called RLE iterator. It takes in an array A. An array A is a run length encoding of some sequence. So what a run length encoding means is that um, so for index of 0, if we have index of 0, 3, and index of 1 is 8, that means that we have an array of 3 eighths, right? And then similarly, if index of 2 is 0, and index of 3 is 9, that means that we have 0 nines. So taken together, if we have an array A that is 3, comma 8, comma 0, comma 9, that means that we have 3 eighths. Um, so the next part of this problem is that we have uh, a command called next. So this class RLE iterator that you create must have a function or command called next. And then what next does, or what the problem wants you to do with next, is to be able to exhaust two terms, like exhaust n terms of the sequence. So next two exhausts two terms of the sequence and returns, like in our example, it will return 8. And then if you do next again, it will exhaust one more term of the sequence and return 8. And then if you keep exhausting and it's outside of like if you do next two and then exhaust two terms and it's outside of the array that's encoded by 3809, it will return -1. So all right, so then my first go at this, I did just I just did I just made I first decoded the array. So I first made an array based on the array A, based on the run length encoding, and I ran into the problem where I cannot. I ran out of time on very large arrays and very large numbers, um, and so then I decided the second time to go at it, I was gonna go by using the run length encoding because that should save time if I were to do the calculation based on just the indexes itself. So not making my own decoded version of the array. So by that I mean that if I were to have an array A called 1, 2, 3, 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, like this would translate into 2, comma 4, comma 4, comma 4, comma, and then 5 sixes, like 6, comma 6, comma 6, comma 6, comma 6, and then 7 eighths. So it'd be 8, and then 8, comma 8, comma 8, comma 8, comma 8, comma 8, comma 8. And then you see that if we were to have A be sent into, if we were to create an LRE object, so if we were to create an LRE object called RLE in this case, and we were to pass in A, when we do a.nextn, we want to have a function that can uh, use it directly on this encoded version, this A, where A is equal to 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8. And then so then you see that if we were to have the red index at index 0 of A, red arrow, we have a red arrow pointed at the index 0 of A. So I like to use rainbow colors, so I always start with red, orange, and yellow. So we have A of 0 being 1 and the A of 1 being 2. So now we know that in the decoded version it would be 1, 2, right? And then we see that if we were to do RLE and then we do this, we do the function next 5. We see that 5 is greater than 1. So it will definitely step outside. We would definitely need to move the index from this red arrow here and look at this orange arrow here. And then when we move it, we need to also need to account that we exhausted an element, because there's 1, 2 that's been exhausted. So if index 0 is 1, that means that there's one element, and this element in this case is 2. So a of 0 is 1, so we exhaust one element at this index, so it'll be 5 minus 1, so we still have 4 more to exhaust. So if you look at the orange arrow next, we see that this that a of 2, a at index 2 is 3. So there's 3 elements to be exhausted. So then we take 4 that we need to do, and we subtract out 3 from here, and then so we exhaust 3. So now we have done 4 out of 5. Like, we've exhausted 4. There's still one more to exhaust, and we see that one, like we need to exhaust one more, and at the next index, let's say the yellow index of a at 4, a at index 4, it is 5. So we have 5 6s, right? Because like a of index 5 is 6, and a of index 4 is 5. So we need that. We know that when we exhaust 1, we would remain within this index, and so we should return what is in a of we should return what is in a of the index 5, which we return 6, which is right in like basically. So we can see that there's a common pattern. We can just have a simple for loop, and we can just, or like a while loop, and then just like while the exhausted, like to be exhausted number, or like the number that needs to be exhausted still is if it's greater than the number at the index, at one of the red arrows or orange arrows or yellow arrows, like if it's greater than the number at the index, then we move the index to, like, we move the index, like I plus equal 2. We move the index by 2, upwards by 2. And then we look at the next one, and then if the number that needs to be exhausted is still greater than that, we move to the next one. If the number finally is less than the number to be exhausted is finally less than the number at like the index, the even number index, then we look at the index, and we look at the a index plus 1. We look at the next one, which would be the number or the element that it describes. So then we can return that element. So if we stop at at index I, then we look at the element, then we return element a of index I plus 1. So that would be how we would approach this. And then we can see that if we were to continue with the function, we do next of 5 dot next of 1, then we have to use the remainder that we had at next of 5. So if we were to do RLE dot next 5 dot next 1, then we would need to have the remainder from the next 5 be added to this new value, this new 1 that's being put in. So we have to do, so if you look at it, we remember the 1 was the remainder, or it was like the amount that was exhausted at the yellow arrow index, or a at index 4. So we know that we would have to do like basically 1 plus 1. So we need to exhaust 2 elements in the the array's index 4. So 2 is still within 5. So it's still within. So we don't need to move our index up. So we just return 6, and then we save 2 as a remainder. And then if we were just to let's do like a more extreme case. Let's do it again. Let's do next 10 on top of this. So RLE dot next 5 dot next 1 dot next 10. we see that, okay, since our remainder was 2, we use 2 plus 10 because 10 is new input. So now we have to exhaust 12, and our index is still at 5. So in this case, if we were to run like a while loop, um, so while, so you see that basically the if it's greater, then we would have to keep moving the index up by 2. So we can see that we do have to move the index because 12 is greater than 5. So so then in our while loop it would be like, okay, we gotta move it up, and then we have to subtract 5 from 12 because we it has satisfied, like we once we move to the next from once we move from a of 4 to a at index 6. So once we move from a at index 4 to a of index 6, we see that a of index 4 had described 5 elements. So of the 12 that we need to exhaust, we have exhausted 5 already. So now we only have 7 more to be exhausted. So then we do, well, in our for in our loop, we see that 7 is within the index at the green arrow. 7 is within the a of index 6. So we know that it is within it. So we stop here, and then we just return what the green arrow's um, element that it describes back, which is a. So since we stop at the a at index 6, we return the element at a of index 7. So in this case, a in the second is a, and then we return 8, and then we save 7 as a remainder. And that's how this approach works, and it should be much faster because you are using an encoded array. Thank you for your time.